Yeah,
Beautiful.
hi everyone. Thank you for joining us today. We're excited to present you a great topic, great webinar, and co-hosted by the New York Oracle Users Group and Oracle Partner Viscosity North America. So feel free to submit questions in the Q&A field, and let's make this webinar interactive. This webinar will be recorded and you can rewatch it so anytime and download slides at orapub.com. And we have Coleman Levita, the VP of New York Oracle Users Group. So I will give you can introduce New York Oracle Users Group, right?
Yes, thank you, Alina. So the New York Oracle, go to next slide, please. The New York Oracle Users Group was founded in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. And you can connect with us on either LinkedIn, next slide, please, Alina, LinkedIn, uh, Facebook, X, and of course our website, NYOUG.org. And all the webinars that we've co-hosted with Viscosity for the past, I believe it's 4 years, soon it'll be going on 5 years, can be found both on Viscosity's website as well as the New York Oracle User Group website, NYOUG.org, category presentation/webinars. Have any issues, you can always contact us from the website. I just want to turn it back to Alina, who will introduce the viscosity, and then I'll just introduce Habib.
Thank you. Thank you, Coleman. So about us, Viscosity North America, we are a leading Oracle consulting firm specializing in Oracle database services like REC, Apex, performance tuning, and high availability. We have 6 Oracle aces on our team, and they wrote a bunch of great books and deliver unmatched expertise and hands-on solutions. You can visit our events page and check out what's going on there. We own orapub.com. It's a training hub, and we provide valuable workshops, exclusive webinars, live virtual classes to help DBAs and developers stay ahead of the curve, including on Oracle Database 23 AI. And please follow us in social media. Yeah, we are doing great content and a lot of videos and valuable stuff. So, and if you have any questions regarding our services or training on our pub, just reach out to us. Yeah. Now, that's all from my side. Coleman, now you can introduce our speaker today.
Okay, thank you, Alina. So Habib or Rahman, a principal product manager in the Oracle Database Organization for Oracle Globally Distributed Database and TrueCache, bringing extensive expertise in Oracle database technologies, including real application clusters, data guard, Golden Gate, and performance tuning. Additionally, he possesses deep knowledge of Oracle engineering systems such as Oracle Exadata, Exadata Cloud, and Customer, and OCI architecture and solutioning. Habib has also held the position of Oracle Pre-Sale Solution Architect, leading Oracle engineering system. I just want to thank Habib for presenting the webinar today and for Viscosity for co-hosting these series of webinars that's been going on for at least 4 years now. And all these, this presentation will be on the Viscosity website as well as the NYOUG website. Thank you very much. And Habib, the floor is yours.
Sure, thank you. Give me a second, let me share my screen. I hope my screen is visible to you, right?
We can see your
Let me
screen,
know.
Habib.
Okay, thank you. Okay, thank you, Coleman, for introducing me here. Hi, everyone. My name is Habib Rahman, already introduced by Coleman. I'm the principal product manager for Oracle database, globally distributed database, and the True Cache. So in today's webinar, we'll talk about detail of what Oracle globally distributed database is and what are the true cache we have. So let me start this initially. So if you see when you talk about the distributed database, because this is something new, in fact, I mean, not new, in fact, because this is already there, in fact, since a lot of people using it, a lot of the third way to using it. But if you see the distributed database, nothing but say it's like simply a database that stores the data across the multiple physical location instead of one locations. Okay, and each location stores a subset of the data, and the data are distributed in such a way it's hidden from the application. No application knows that data is getting from single point, but in the reality, it's being virtually distributed. If you see here, this is a kind of environment here. If you see here, this is called application. Now, this application is going to get the data from any other location. Now, these locations could be they are located from different, maybe the data centers, different places. This is what we call is the database, which are distributed across the different physical locations. Okay. Now, if you see this Oracle database, it became the distributed database in 2017, actually. Now, if you do the Oracle, I mean, we started a concept called sharding. In 2017, we used to call it shard, actually, right? Now, this become a distributed database somewhere in 2000, in fact, when we got 23 actually. And it was using the same power, same thing, to basically we have something called the Oracle native database where the sharding was built in 2019. And then in 2023, we have built the new concept called distributed database. So this was used for the many purpose. Like if you see the reality in today's time, we have the mobile messaging, we have the credit card fraud detection, with the payment processing, smart power meter, in fact. All these are the areas where we are using this distributed database actually. Now, let me take two main example, key use cases. With this, I will be able to explain you exactly where we use this database. If you look at reality, this distributed database has two main purposes. One is to give you the ultimate scalability and the survivability. And the second is called transparency, transparent data sovereignty. Now, that scalability talks about where the data are distributed and replicated across a multiple, location, in fact. And this database gives you hyperscale and the fault tolerance, if you talk about in fact. The second one talks about the transparency over the transparency data sovereignty. So data sovereignty become a quite common thing nowadays, because if you take example, like suppose you are a application owner and you want your data to be distributed in such a way, because nowadays every country has their own regulations, right? Which they say like the data of respective country should be there. Like suppose the data of US should be the US and the data of India should be India. So if you have such kind, because in India we have multiple, we'll talk about the use cases there. So when we have such kind of regulations where the data is cannot be relocated, co-located to other country, the data sovereignty which call normally. So those are the case. So these two are the main cases where we can see the ultimate, like all the banking sector nowadays, which they use applications, right? Now, customer may be present in India, customer may be present in US as well, right? So if you talk about any bank which bank has a branch in both countries, So in that cases, naturally, every country like RBI in India has a rule that data which exists in India should be in India. So these two are the very important use cases we talks about here. Let's take detail of this thing. Okay. So now from this diagram, I'll try to explain you exactly what I mean by shard. See, shard, if you look my picture diagram here, we have three shards: shard 1, shard 2, and shard 3. Red shard, green shard, and the blue shard, right? Now, these are nothing but say one physical database is divided or distributed across the multiple databases, and each database we call as a shard. Now, the beauty of this shard is it does not share any hardware. It shared nothing, something called, we call something shared nothing architecture. Okay. And data in each shard is replicated for solvability. In case if one shard goes down, it should shoot two shards can serve the purpose, right? And this is something also called the active-active architecture. Means at any point of times, the data will not be lost. The application will be able to get the data because all three data are having the subset of this thing, right? I told you a single logical data. Data is physically distributed across the multiple database, which we call shard, and data in each shard is replicated for servability. And the all shard can process application request. This enables the active-active architecture, and data can be distributed across the multiple shards. Okay. Now, data this shard can be anywhere. This shard can be on the prem. This shard can be also on the let's say cloud. It could be also multi-clouds. Anywhere it could be here. Now, the benefit, one side idea, the benefit of sharding is, look, hyperscale is nowadays is the main talk of things, right? Like we have the like sometimes when we have the festivity season, right? Now in the festivity seasons, I told you every shard has the data, right? Suppose if some festival has come up, right? We have the option to hyperscale the shard. We can add the shard, we can remove the shard online without any, in fact, without any downtimes, with minimal data distribution. So this gives you a power to add, remove the shard based on your convenience. Okay. Second is called fault isolations. Obviously, in case you have one big database, right, which goes down, naturally you're going to lose the data. You lose your continuity from the application. So that monolithic gets broken into multiple distributed database, what we call the fault isolation. So in the case of fault isolation, what we do is we create the shards, and each shard has a set of data. So in case if, let's say example here in the picture, if this shard, let's say green goes down, initially we have red shard, blue shard, and the yellow shard. They can serve the purpose. So this is something called fault isolation. And the third is called data sovereignty. Data sovereignty is one of the key topic of things. Like data can be distributed across a multiple country depending upon the sharding keys, right? So there we have something called user-defined data. It means you can move the data. You can say like the data of the US citizen should be in the US and India citizen should be in India. So that kind of the flexibility we have. So these are three major benefits which sharding gives you. And if you talk about this part, which we call as the distribution of the data in from application. So this is a reality actually. If you see, the distribution of data is hidden from the application. Say, when the application connects here, let's applications here, right, with the send the request here. This application doesn't know from where it's getting the subject purpose. So from the application, this data is hidden. Now application request can get the data from the single shard or the multiple shard, depending upon the type of query written here, right? Request that need to be like when you say like the data, if you want to use data from shard 3, you find the command, this thing. We have something here between, I'm not sure the diagram here, something called the shard coordinators, which you call the catalog, in fact. So the catalog used to define that from where this particular key is lying, and based on that, is pull the data for you. So requests that need data from the multiple shard are automatically split in this split. Now, this is the next kind of generation where the data can be achieved from the distributed database. And also, this allows you to place the data in the multiple geographic location in any other country you want. So this gives you the wide angle where the single database can be scaled, can be used for survivability, and this can be also, each shards are, we call, independent to each other. There's no dependency at all actually. Now let's take an example here, a couple of examples to explain exactly what it is. Now here, the data sovereignty, let's say take for example here. Now, I told you this data sovereignty become the mandatory in the many countries like India, other countries, especially for the payment database. Now in India, the Reserve Bank of India, it has something called the data localization regulations. Now the data localization regulation, which says that the payment data must reside in India if the both payer and the payee are the Indian citizen. Similarly, this applies to US as well, other country as well. Now, this is something you can say a showstopper for the global financial services companies. Naturally, every bank faces this kind of issues, right? When the data comes, because data, no doubt, is the key for everyone, right? Is the data is everything for us today. So data has to save, has to secure, has to place such a way that people who belong to the country, they can access the data. So there's one of the major area this is going to do. And also that store the data from the country in the single database, right? Now, the key observation here is that the data must be physically stored in India, but it can be accessed from anywhere. This is the beauty. I mean, it's not required. The data can be in India, but the application you're accessing, you can access the application from anywhere in the world actually. But the data from where country you want, you can access from there only. So application need not to be like, fine-tuned. It's the same thing. What we do, only change the architecture of the current layout so that data can be split to multiple countries based on the regulations. Now, take example here. We have, let's say, one of the largest US bank, which we have done this re-architecturing in the recent past. They wanted us to do the kind of, solutioning where the US data and the India data, they can lie into their own areas, but the application which was there, that was not changed, that can be anywhere actually. So here in the case, you see here, we have the US East Coast and the West Coast, right? Now here we have the replication disaster recovery for call the NG. And what we did is, we initially, the US, this machine is hosted, if you see previously, this machine is hosted on Accelerator machine, all right? And the application and the database TS are replicated across the regions inside the US for data recovery. Now, Oracle Global, when you place this concept called Oracle Globally Distributed Database, what exactly did it is, it enables a bank to easily comply with the India's regulation, which RBI has mandated us. Also, the new shard were created in India to hold the India data. Now here, if you look this diagram here, this shard was created here or created here. So this shard is not going to hold any US data. The India shard is going to hold India data, and the US shard going to hold US data. Now, this gives you new database architecture. It required very, very minimal change the application level. Maybe the connection string are not change required, but there's no high major in fact change required. Also, the high complex application TS did not need to redundant deploy in India. Now, in case here, in case if it was not their case, then you would have to also deploy the same concept, same application in India as well. But here, we didn't touch much to application, only minimum change we done for application. Whereas we have sharded the database and we have made such a way that the Indian data, India's shard and US and EU shard. So that gives the compliance which respective countries bank system, right? Now, one thing is guaranteed that the regulations will be increased here. Also, if you look the other example here, I have this is something called the Blue Kai, right? Blue Kai, if you take, is basically it's a leading data platform for the digital marketing campaign, right? The data is accessed in real time by the hundreds of millions of consumers as they surf the internet. Because this is totally, say, like digital platform campaign. So naturally, when you surf the internet, right, it traffic increases. So this is something called accessing the real-time data from the internet. So naturally, every time it's maybe hundreds or millions of connection consumer they're using, right? Now, Blue Kai is basically hyperscale workload. It is on the multi-petabyte database that requires near the instant response time. Obviously, in the internet, when you access some data, you don't need to wait for that. You just click it, you should get it, right? So when you have this kind of things, obviously you should have something very uh, agile kind of thing, something quick kind of system, right? Now, if you see the figure here, it processes around 1 million transactions per second, and it works almost 30 billions API per day. Such a huge system we have, right? With response time somewhere 1.6 milliseconds, right? Now, if you look this number of machines, if you look here, Blue Kai now runs on the Oracle globally distributed database. It runs on around 104 community server, and which community has something called 5,408 CPU, right? Close to 77.4 terabyte of memory. And it was migrated from the combination of NoSQL. In fact, if you talk about the Blue Kai, it has a multiple combination of databases. Now it was combinations of the like product called Aerospikes, Cassandra, Scala. It was there. So we migrated from there to Oracle Global Database. Now the simplicity of the architecture, it gives you the same simplicity, plus it inherits the entire capability of the Oracle SQL Power as well. Now, this is something like, I mean, this kind of innovation, we have something which no one has actually, right? Now, if you look at the architecture deployment here, look here, this one. Look, we have 1, 2, 3, 4, 5, 6 data center actually here. We have 3 data center here. Data center 1, 2, 3, right? Each data center, they have replica. So now if you see any point of time, like if you see the total data value is something 2.5 petabyte, and it is distributed across the multiple data centers. We have 3 data centers out here, right? Each of the shard in the data centers has a replica in the different data centers. So that if one center goes down, replica goes down, the application can serve the purpose from the available data centers. Hence, enabling the Blue Sky to survive an outage of entire data center. If you see example here, in case if the data center one goes down, entire thing goes down, even though you have the, now from here, this is called red shard. Now the red shard is available on here, data center 2. The green shard, green shard is available here. And blue is, in fact, the green is here, blue is here. So if data center 1 goes down, even though in that case we have this survivability to get the data access from the other data centers. So this is something very robust, very scalable solution, right? And along with this, Oracle is the only, company which has the more data distribution method than any other commodity hardware, any commodity of computer actually, right? Now, Oracle gives you 4 types of data distribution. Now, let me tell you what distribution in fact is. See, in the Oracle database, when in the sharding, basically, when you do the sharding, we do the architecting, you need to define that how you're going to create the shard on this table. And then you define which kind of sharding method, I mean, sorry, which kind of the distribution method you're going to use, which you call data distribution method. Now, this gives you 4 options. One we call is list value-based systems. Second is system defined. Third is composite, and the fourth one is called directory-based sharding. So 4 types of sharding we have, and believe me, we have many competitors like in this system, but I think maximum 2 or 1 exists with them actually, right? I can't name it right now here which competitors we have. Okay, now look, the first one is called the value-based system sharding. Now, the value-based sharding distribution, this distribute the data by the value. For example, a country code or the product ID. Or you can distribute the data by range of values, something called say range of phone numbers, right? So first one is called the value-based data distribution. Now, second method we call is the system-based sharding. Now, system-based sharding, distribution is basically it uses the consistent hash algorithms, right, to evenly distribute the data across the multiple shards for the scalability purpose and for the parallelism purpose. For example, we want to distribute the data by customer ID, by device ID, by item ID, right? We can do this way. And the third way is something called consistent hash. Now, beauty of this is the consistent hash. I mean, it also allows to enable the additions of shard online without any kind of downtime with minimal data movement. Now, third type of sharding we have in Oracle is called third type of distribution we have called composite data distribution actually. Now, composite data distribution, it uses two levels of sharding with two different sharding keys, right? And with two different sharding methods. Normally, if you see, it's the combinations of the user-defined and the system-defined sharding. Now, data is first distributed by the value, for example, the country code or the range or phone number, and then that distributed by across the data center, and say, for example, the customer ID. And second sharding key is using the consistent hashing. So these two are four types of shard distribution method we have. Now, this is user-defined. The user-defined sharding distribution has its own specialty. Like suppose there are sometimes required, like you have something called the skewed data, right? Skewed data we have, right? And you want to do the manual intervention. You want to you want to distribute the data based on your requirement. Suppose you want to say, you want to move some set of data in US, some set of data in UK, some set of data in India. So if you have such kind of system where you want to define the sharding based on your requirement, that's what we call user-defined sharding. In the user-defined sharding, you have the complete control on this. Like how do you want to place the data, right? This is basically, if you take example from here, we have, let's say, Taylor Swift shard, Beatles shard, other shard. Now here, if you take example from here, now we can store the Taylor Swift and the Beatle data in their own shard, and we can combine the smallest artist data together in the separate shard. So this option we also have it. Like suppose you want to store in separately, like based on requirement actually, right? Now, there's something called duplicated distribution. I'll tell you exactly what it is. Like when you create, when you identify the number of tables you want to do sharding, right? Let's say you have, example, you have customer data, you have say like item data, and say you have many invoice data, something, right? Now these three tables, you say you are going to shard them. But you have, let's say, one table called product item table. Now, product item table is a very small table, right? So in case you want any table which is very small in the size, you don't want to shard them. So you can duplicate them, and they will be placed in all the shards, right? Generally, when you do duplicate distribution, that means you are not sharding the table. So in case you want to store them, you want to keep them, you don't want to, because the purpose of this one is to avoid the any kind of cross-shard queries or any kind of cross-shard referential intent checks. In case you don't want to use them, you want this very small size. So you can put this particular table, say product table or any info table, in all three shards. So that's what we call the duplicate tables, duplicate data distribution actually. Okay. Now, we also have the beauty in this case, Oracle support the partition data distribution within each shard. Now, For example, the data in any shard can be further be partitioned by the data values, such as the data range. Then further we can partition by, let's say, data value or the hash. Now, this enables the fastest query and join within the shard. Shard can be also added without any incurring any downtimes. Let's say I told you, if you have seasonality, you have some festive season, right? Now, and you think the data workload is going to increase on my system, and maybe during, let's say, Christmas time or maybe the Thanksgiving times, maybe I can get unexpected a kind of traffic, right? So in those times, you can add the number of shard, maybe depending on my requirement. And when the season goes off, right, of the season, you can remove them, right? So adding and removing the shards is totally automatic. It does not incur downtimes. And also, it gets automatically distributed across the shards. You don't need to distribute it, gets automatically distributed. And third is, this enables you something called a scale out or a scale in for seasonality, told you, right? Now, data across the shards is automatically rebalanced with minimum data movements. And this is something online operation does not require in kind of the downtime. So this feature we also have in the case of sharding. Now let's understand the replication methods. See, Oracle no doubt has more replication than anybody else. You know, two common replication, maybe since in the group, maybe most of you also gone through this DBA kind of things. In Oracle database, we have two major kind of replication. One is called Data Guard, ADG, and the second is what you call the Golden Gate, right? Now we have third one is called Raft-based replication. This is basically the features of 23AI. It is not a feature of 19C, it's a feature of 23AI. Now, the main purpose of the base replication is basically it works on something called the Raft quorum-based replication methods, protocols. Now, this provides you the automatic failover to a replica under under 3 subseconds. Now, if you see from this diagram, maybe next time I can explain very nicely. Now, the purpose behind this is to implement an active symmetric configuration, and each shards which accepts writes and the reads for the subset of data. It also delivers the zero data loss using the high performance synchronous replication across shards. Now, this is similar to Cassandra. You know, I think you all like Cassandra, right? Cassandra is something called open source that does not use a Raft, but it has a notion of something called replication factors. Then we have something called data stack. Data stacks do not use Raft-based replication. It uses something called Paxos, but they are trying to move to Raft. Then we have CockroachDB. It uses Raft. Yogabyte use Raft. Google Spanner use Paxos, and the MongoDB use Raft. Okay. Now the purpose thing up here is everybody uses it, right? But Oracle does something different way. It uses a different way. Now the capability, the features, the functionality, everything which Oracle has, that other vendor do not have it. I will prove that as well. Now here, if you look this diagram here, I think most of you know, right, what exactly the meaning of the Raft, right? Because Raft is something new, not new, something old concept. Now, customer can define the replication factors. Say, example from here, we have 1, 2, 3 shards, right? We have 3 shards, right? Now, each shards, if you look here, the asterisk, this asterisk is called leader, and these two are the followers. Now, if you see first diagram, first shard, the green is a leader, red and blue are the followers. In the second shard, green is a followers, red is a leader, and this is a followers. So every asterisk is a leader, and there's 2 of the followers. Now, here we are going to have 3 copies of data, 3 copies of the data. So what to do is, customer has the option to define the replication factors that is equal to copy of data to be stored in the distributed database. Now, this is similar to Cassandra, okay? Now, if you see picture here, I told you, we have 3 shards. right? 3 replication factors, which implies 3 copy of data across a multiple 3 shard. Now, asterisk indicate the leadership of the subset of data. There is something like green, blue, and the green, red, the blue, and the rest 2 are follower. Now, leader has a power. What power leader has it? All the reads and the writes by default are routed by the leader, not the follower. Upon writing the leader, the replicate the data to the followers upon establishing the quorum. Now it is a quorum. Quorum is basically established when you want to commit the data, right? So quorum is established. In fact, Oracle has multiple types of option. We have it here, but let me give you this standard one: 2 of 3, 5 of 7. 3 of 5, 4 of 7. These are different types of quorum. Like if majority of the followers are ready or acknowledge these things, the data to leader, it get committed. This is how it happened actually. So I think most of you must be aware this, how the quorum get established, how this draft works too, right? Okay. Now in the case leader get failed due to some reason, let's say leader failed, right? I mean, it's the due reason. Now all the followers within that leader, they want to compete to become a new leader. Now, if the moment the new leader gets established from the follower, what happened is, this has happened because of the Raft protocol. After that, all the reads and the writes are routed to the new leader. And applications being sent, the ask to route the request to new leader, not the old one. Okay, so end-to-end applications failover is less than 3 subsequent. And also, when you define this, when you go for the Raft-based application, you need to very sure that what latency between the DC and the DR. That should be the important things. Okay. Now, along with this, Oracle also has 2 more types of replication. I think most of you know, right? This one. The first one, which call is redo log, right? The redo log queue. So Oracle also support redo logs and the golden gate. So in the redo logs, it supports the redo log using this is called active data guard that provide the faster the performance and most comprehensive SQL functionality, right? It's called readable replica, provide the simple operations. It also supports the SQL level replication. That is what we call the golden gate, right? That provide the faster failures, fully writable replica, including the conflict avoidance and the resolutions kind of option. Okay, so these 3 types of replication we have Oracle. So I think last 2 redo levels and the SQL levels, I think most of you know, right? Because this is a old thing. Now this Raft-based replication is something new which we have introduced in Oracle 23i. One more thing before I move further. If you have any questions, please put in this chat. I will give you, in fact, 10 minutes time. Then we can discuss the any kind of thing we have. Okay. Okay, now let's see the deployment options. If you look the options where you can deploy the shards. So Oracle supports, in fact, every platform. You say on-prem solutions, you want to deploy on the community hardwares, Exa machine, we can do, in fact. You want to deploy in the OCI cloud, you can do this thing. You want to apply in a multi-cloud, something called Azure, AWS, anywhere. So Oracle gives you the variety of options. There could be possibility, maybe when you start working with this sharding, this shard concept, you might come to know there will be a customer who wants one particular shard in on-prem, second shard maybe on a multi-cloud, third shard maybe in OCI. So even all that kind of option we have it actually. So we do not, I think you talk about any competitive like vendor which provide the which provide the distributed database, do not have this option actually, right? Now, let's take an example here. This is basically a feature of Oracle 23i. Now, Oracle 23 actually, this is not the topic of today actually. The topic of today is different thing, the distributed database and the true cache. But yes, we have the options where Oracle natural language can be used. So let's go back to look at these things. Now, Oracle 23i brings something called natural language query to globally distributed database using the autonomous database Select AI. There's something called Select AI, right? If you can Google to Select AI in the Google somewhere, you can get this blog out there. Now, it can translate the natural language into natural language question into SQL, like you see my screen here, right? They're using something called AI large learning model. The SQL query is automatically routed to the appropriate country or the shard by the global distributed database. For example, if you want to ask a question, say, how many total streams for each Tom Cruise movie were viewed in India this month? Now, in this case, the large learning model generated a SQL, which already has a country code as India, and hence the Oracle globally distributed database route this query to the shard in India. So see exactly here, you can get the output here. Now, this gives you a kind of flexibility, in fact, where you can route the query. Basically, query routing done automatically by the query coordinator, actually, which we have in the sharding. But yes, I mean, this is the option we have. And the second feature I want to talk here is called AI vector and the RAG, actually. I think, again, this is not topic of this, but yes, AI vector search and the RAG, what you call the retrieval augmented generation, is also available with Oracle globally distributed database. And Oracle distributed database will add the hyperscale and the data sovereignty to Oracle database 23i vector search. The customer will be able to combine this similarity search using the AI vector. With each search, the business data can be customer and the product in single distributed. Now here, we also have the same feature like the Oracle globally distributed database is also available on the autonomous database, right? It's available actually. Now here, we can like add the autonomous management to basically the purpose of the autonomous concept. We see maybe, like ADB, right? Autonomous database, dedicated and the shared one, right? We see ADB, basically ADB has the feature which eliminate the operation complexity, right, of the distributed database, and it reduce the cost, right? It's a combination of globally distributed database with Oracle autonomous database, right, which enables you the Oracle globally database to be online. I mean, to be accessed from the cloud as well. And this is basically hosted on Oracle's cloud native distributed database services. So we can also access, in case you want to access the Oracle globally distributed database, you can access even the Oracle services, OCS services as well. So OCS services, you have, in fact, either you can access, either you can install it in your, let's say, a machine, you can access it, or you can access through the Oracle OCI. Also, we have something called Oracle Live Lab. We'll talk about later on this thing. So we have multiple ways to access these things. Now, one very important thing from here to key take is what exactly the key take here is. The key purpose of Oracle globally distributed database is mostly fully featured distributed database. It provides a more data distribution than distribution method than anybody else. It has a lot of also more application than anybody else. Also, it can be deployed on prem, also on the cloud as well. It's also called something converged database architecture, right, which makes the data sovereignty easy for the modern application. They can use a multiple data types and workload. The Oracle 23i Raft-based replication, it provides the fast quorum-based failover, right? It supports also something called leading edge AI select and the vector search, and the autonomous capability to remove the complexity and reduce the cost. So beauty of this is, you see here, I have given some link here, in fact. So now this link is in case you want to access the Oracle database Raft-based application, how the replication works, right? You want to see the hands-on, right? Nothing theoretical, full of hands-on. So we have something called Live Lab. This is free of cost to access. There's no charge for anything. You just need to click this link. Once you click the link, it will open the link straight away. And there you have two options: to create a sandbox, or to like spin up a sandbox, or to host on your own tenancy. In case you have any tenancy on the OCI, you can build it, this Raft replication, and you can use anytime. But in case you do not have any tenancy out there, what you can do is you can use that particular sandbox. Just click on this. I think maybe it'll take, I think, maximum 10 to 15 minutes. The sandbox gets commissioned for you. And straight away, you can go there and you start working on this. Even that sandbox will be having all these steps. We have, in fact, 1, 2, 3, 4 multiple steps there to show you that how to access this thing. And also, you have the screenshot, you have the command, everything there. So in case you want to do any hands-on, you want to get your hand dirty on this Oracle database, distributed database, you can work at this way. So we have this data 70 in a good distributed database. We have Quick Start, DBA. So every link I have attached here for your reference purpose. But I will advise all of you, just go and try the Live Lab. This is free of cost, the thing is there. Just click on this, and maybe within 10 minutes, the sandbox gets provision. And then from there, you can try everything. Every command steps there, actually. I'll do one thing, maybe after end of this presentations, I'll try to show you how to launch it and how you're going to work for you, look for you. Okay. So before I move to, okay, I have two questions. Just do this. Yeah, this is right now, Mr. Pete. This is right now dedicated, not the serverless. Only we have for dedicated, not serverless. Yeah. Okay, this data is sent. You said how data is sent to a specific shard is a partition based or the subkey. Basically, what happened here is when you define the shard, right? And let me explain you. When you say you want to shard your database, right? So first and the foremost thing is you need to find out which table you want to shard it. Let me take example. You have table called customer, right? In the customer table, first question here is which of the column is going to be sharding key. Now say you are saying that, let's take customer ID. Now customer ID will be, yeah, serverless in our roadmap, in fact. Yeah, that's true. Now customer ID will be your sharding key. Okay, you define this thing. Now, once you define these things, now next step is this: how you going to distribute database? You distribute database based on user-defined shard, system-defined shard, composed shard, or the activity shard. So let's say you take a system-defined shard, right? So system-defined shard, I told you, it generates something called the Aura hash, something called hashing algorithms, right? So the moment when you run the query, it says select star from customer. Now you have two ways to run the query. One, provide the sharding key like this: select name from customer where customer ID is 123. The moment you say 123, that means you give the sharding key. If the sharding key is provided in the query, that means this is single shard query. There we have something called the catalog. Catalog has all the information. Then we have GSM, that's called the list and directory, you can say. The GSM knows which particular shard ID belongs to particular, this particular shard ID, sharding key belong to which particular shard. So if you provide the sharding key, in that case, that shard key reside any of the shards, say shard 1, shard 2, shard 3, you get the output straight away. That's what you call the single shard query. In case you say select star from customer, no sharding key. In that case, what happens? The catalog will be generating a kind of parallel threads to all the shards, and they will run parallelly, something called scatter gather concept. It scatters all the data from there, run the query through it run the parallel queries, get the data, gather it, and send back to the application user. So that basically defines, like, I mean, when you say system defined shards, the system defined shards, every shard, as I told you, this is uniformly distributed. Suppose you have 3 shards, and suppose you have 1,000 data. So you may see 3,003 data on all 3 shards we have, and plus also last 1,000 data will be distributed equally. So in the case of system defined shards, you don't have to define that where this particular data has to go. This will automatically taken care by the system based on the hashing algorithms. If you say user defined shards, then you have the options to define that this particular shard, let's say data of the US, data of the Indian citizen, it has to go respective shard. So those options we have. Yeah, I hope I understood question. Yeah, Pete, the question is, serverless is in fact on the roadmap. Yes, but right now we have this globally distributed database only on the ADBT. Yeah, thank you. So this live lab, in fact, I can maybe after, if it allows me time, I can show you that how you can invoke this thing. And if you don't have any questions, we can move the next topic. Okay, yeah. Now, next one, in fact, here I've given the link as well. If you can click on this, any of this thing. Also, I've given my email ID as well. In case you have any specific question to ask, or if you have any use case, if you have any customer you want to us to do any kind of POC or something, I'll be more than happy to, you can reach out to me and we can take it offline. Yeah. Now, next is called True Cache. Okay. Now, True Cache is basically, let's go to talk about it. True Cache is something you say is a key feature of Oracle 23i, right? Again, the True Cache is not available in 19c. Similarly, the Raft replication is not available in 19c. Now, these are the features of 23i, which you never had before this. Okay. So to accelerate your application, right, in the traditional, what happens to accelerate your application performance with a True Cache, what we do, we use the True Cache SQL and object cache, and this is generally used to accelerate performance of your application. And we use separate kind of cluster caching. For example, there are many kind of cache provided in the market. This called Redis or the Memcache. Memcache, right? These two are the. Also, we have Aerospec as well. Now, these are different types of cache mechanism we use right nowadays. Now, the only problem with this cache has multiple things. Okay. Now, reads, the purpose of cache is that to get the benefit of read, right? Benefit should be offloaded, right? Now, the conventional cache, you say Redis or the Memcache, they have certain limitations. They also had the problem issue, the performance issue as well, right? Now, if you look, what is the difficulty we have in this traditional cache? The first is the developers are responsible for loading the data to the cache when the application starts. You take example of Aerospikes. If you reboot the Aerospikes, it takes hours to come up because it has to warm up the cache, everything, right? So the problem is in the traditional cache is the developers are responsible for loading the data into cache when the application starts, right? Now it read the data from the database, okay, and then load the data into cache. Subsequently, on the each cache miss, in case is any cache miss actually, the application reads the data from the database, right? And again load it from the cache into the cache. Then return the data to application. So now, the thing is here is every times if something cache missing, something happening, the developer has to write some kind of code where he has to bring the data back from this cache. Now, this is one thing here. Second is this, in such scenarios, developer have to write the custom code. Give me a second, I'll answer the question. Now here, developer, as you're saying, the developer has to write the code, custom code, right? For loading the data in the conventional object cache. Now, developer is also responsible for cache consistency within the database. And the second is data in such cache become stale, become old in the database, in fact. And developer has to write this custom code to keep the data in conventional object cache sync with the database, means cache and the primary database, right? Now, some cache works around by this, allowing the application to configure there's something called time to live concept, right? There's an option called time to live. Now, in the time to live, it allows you for data to be cached for a certain period of times, okay? But in the reality, it doesn't work well, okay? Now, second thing is issue happen is there's a frequent invalidations which reduce the cache effectiveness, because obviously after a certain time, if you say you have updated a table into, let's say, your primary database, right? If the primary database is not updated into cache, is not pushed into cache, right? Naturally, the data will become, that data will call stale data, right? Because the data in the cache is different, the data in the primary data is different. Okay. Now, due to this invalidations, which normally reduce the effectiveness, and that add a load to the backend database. On other hand, the less frequent invalidations is only the higher cache for getting data stale again. So additionally, any schema changes in the database can be invalidated, the entire cache. Naturally, if you add one, let's say, table in particular database, okay, and that if it is not, let's say, updating to cache, and you're writing them query, obviously you will get the old data. You're not get the data. So in this case, what happened is the developer has to write the data, has to write this custom code to ensure that you have the consistency within the cache, ensure that the data gets automatically uploaded from the database primary to cache. So that is one thing which normally gives the more issue in the terms of the performance perspective. Now, developer is also responsible for cache consistency with other cache. In conventional cache object, each cache is independently maintained. Like you have talk about the Redis MM cache. For example, as I told you, you have account, right? In the account, let's say you have updated some amount. Let's say you have there's $1, $10. You put $20 more. Now you account, you have $10 in accounts. You have added $10 more dollar. Now the actual answer should be $20, right? But in case your cache is not updated due to some reasons, right? You will get the data at $10 only. So in all the cases, the only problem is this: your as the cache become as the object become as this become bigger something, if it doesn't refresh, if you don't have proper code, custom code, naturally you get the issue with the consistency. Also, in case you have something called complex object, okay, that is not cached, or you say nested relationship, even that is not cache. So all these are the difficulties, issues in the conventional cache systems. And it also has some limitations. It does not support every types of data format. For example, the conventional cache supports limited data types and the data format. Object cache support only the scalar data types, like suppose string type data, integer type data, JSON type data. Okay, data cannot be accessed in the columnar format. This is a limitation of the Redis and Memcache. It cannot be accessed in the columnar format. Say in case you have analytics or the reporting purpose. In this case, this can be very effective. Other hand, your Oracle database supports a rich variety of data. In our case, it supports JSON, we support the text, we support the spatial, we support the graph, we support the vectors, we support everything. Right? It allows us to access everything, in fact, whether this is a columnar format or it is the row format. Now, developer must be handle the conversion between the rich data and the formatted support data by the Oracle database. So that is difficulty. And other big issue is caching the JSON data. The JSON document, you say, it exacerbate the caching problem. The why? Because typically a full JSON document has to be reloaded in the cache, even if one of the attribute in the document change in the database. Because this is very something things in the JSON database documents. If you want to cache entire thing, in case some column or some attribute got changed due to some reasons, you no other option have to change only the miss part. No, you need to reload the entire cache out there. This is something other. This results in increasing the IO load and the backend database load actually. Now, second thing is it has a missing enterprise grade kind of features. Now, such cache has many missing enterprise grade feature. Like for example, the object cache, it lacks a performance feature like multi-threading, parallel processing, sub-partitioning, synchrony indices, many more. All these are is not supported out here. Hence, the large cache cluster is typically deployed. I mean, what actually do is they deploy the large cache clusters, okay, to compensate for missing features. So what they do is they, instead of doing this, they deploy multiple huge clusters. So this thing. So in fact, if you deploy the multiple, let's say, large clusters, obviously you're going to increase the cost, right? Cost burden. Okay. Also, it does not have the advanced security features like user privilege management, or you can say strong encryptions. It doesn't have object level security. Doesn't have. Then row level security doesn't have. Like it does not allow any kind of admin to access the data in the cache. So all these are limitations we have, and because of this, we cannot say this is the enterprise grade feature. Hence, the sensitivity of data cannot be cached. Also, object caching also lack the enterprise grade like availability feature, manuality features, and the observability features, so which typically result in the lower application service level agreement. Now, let's look at what we have, what Oracle True Cache gives you, the beauty actually. Now, if you look here, the Oracle True Cache is basically, it's in-memory consistent and automatically refresh SQL object caching, which we normally call it. That is deployed in front of Oracle database. It handles all the rich SQL, just like an Oracle database. Conceptually, it's a more like a diskless active data guard standby. This you can say, if you see this novel definition, is something called diskless active ADG standby. Data in the true cache is always current and consistent across the multiple tables and objects. Now, if schema change in the database are automatically propagated to the cache. Now here, scaling the true cache with the partition configurations. Now, true cache can be scaled with partition configurations. So there's something new we have out here, which normally other vendors they don't have. Now, multiple true cache instance can be deployed in front of database for the availability purpose. Not only one, in fact, if you want to do multiple caching, you can do this thing. You can deploy multiple caching tiers before the application, maybe for availability scripting, in fact. Okay. To able to, is it can able to cache the large data volume as well. And true cache can also support is pulling data to disk as well. Now, this is something new, in fact. This allows us to cache the data much more data volume than the traditional one. Also, it has a feature which we call the global proximity to applications. Now, for use case like data redundancy, user proximity, and the device proximity, right? Applications are deployed far from the database. Obviously, you have application, it's in India, and database in US, right? So in these all cases where we have the proximity concept, so what we can do, you can deploy for the performance boost, you can deploy the true cache instance before the applications. To boost the read performance significantly, a true cache does not store any data. Also, the good thing is true cache do not store data on the disk by default. Hence, it considered a data processing TS component that decide that also gives you the regulation, like resilience regulation, because some country they also have the regulation as well. Okay. Now, true cache, as I told you in the previous case, in the JSON, if you want to load in the traditional cache, conventional cache, if you want to load the complete JSON document, right? And due to some reason, some problem, one of the component, one of the attribute got missing, you need to reload again, in fact. But in our case, is different. The true cache is a true document and the relation cache with log-free concurrency. This is something new, in fact. And JSON documents stored in the database can be cached in the true cache. Documents are automatically refreshed at the attribute level guarantee. This is something, the new thing we have. Hence, reducing the I/O and the backend database. So we don't have to do these things. We don't have to cache the entire JSON to there. We cache once, but yes, what are the changes we have at the primary database level, that get automatically populated here actually. But the traditional cache is not actually. Now, concurrency is automatically maintained within the versioning. When the document is read from the true cache, there's something called value E tag is enabled, is embedded in it. Okay. When the same document is updated in the database will verify the E tag inside the document and compare it with that in the database. It will show the consistency. Now look here, any change you do in the documents, it generates something called value-based E tag. It embed it, right? So when you do the changes, when you do any addition, any change, update into, let's say, cache, so it checks, so in the database, it checks the both E tag from both places, the cache and the database. If it matches, it updated. Because this level of security, it doesn't support in the traditional database, in the cache. Now, if E tag does not match, then error is reported back to application. And in such case, application can read the document again, then perform the update. So this is avoided to any kind of misleading or the any kind of data breaches. Okay. Now look here, these are the basically, in fact, 9 types of the deficiencies we see in the traditional databases. Now, true cache, one is saying here, loading the cache is done or taken care by the developer team. Cache consistency within the DB is, again, we have to write some custom code to ensure that the consistency between the database and the cache is maintained. Cache consistency with the values in the same cache is again by the developer teams. Cache consistency with this other cache is other developer teams. Complex data support, I told you it supports limited types of data, in fact. Full JSON support is there, but again, we have to write some very custom code to ensure that in case if any of the attribute is missing in the JSON document, that has to be reloaded. So if you look from all these 9 points which are there actually, these deficiencies, these all are governed and owned by the developer. So the responsibility, accountability on the developers increased. So that is something where it incur the good time of the developer, right? But if you look at the Oracle database, in the Oracle database, everything you talk about the first 6 points is fully automated, right? Loading the cache is automated, no developer requirement. Cache consistency by the automated. Cache consistency with the value in the same cache is automated. Cache consistency with the other cache is automated. And the last 3, comprehensive security, parallel processing, and high availability, all these are built on. So now this is the one thing which it differentiate from the conventional caching to Oracle caching. Now let's see how to use the true cache. Now, as you know, the true cache, like the application can query data from the true cache in two ways. As you know, like this, the main purpose behind this true cache is to ensure that the application which is querying the data, which is normally putting the data, doing the select data, it has to do such way that it should get the data much faster, right? Now it can do in two way of like data selections. One, first, the application can maintain two separate connections. One, the read-only connections to true cache, and read-write connection to the database. We have a JDBC driver that has a beauty, right? So we have to define it. The query which you're firing it, which connections do you want to use? Read-only connections or read-write connection? If with read-only connections, then the query will directly, JDBC will direct it to true cache. If it's read-write, it will direct to the private database. Now, okay, now use the read-only connections for offloading the query to true cache. In case you want the data fastest to be retrieved, you should use the read-only connections, because here the data has been retrieved from the true cache. Now here it will offload the data, right? Optionally, the application can also choose to maintain just one connection. Now, we have this something called a smart Oracle JDBC driver that has enhanced the transparency to route the query to the true cache or to the primary database, depending upon the connections you provide, like read-only connections or the read-write connection. I mean, it has a beauty. The JDBC driver maintains two connections internally and does the read-write split under the application control. This is something very different. The application use something called set read-only API call to mark some section of code as read-only. And this is existing the JDBC API, which normally MySQL already uses for the similar purpose. And the JDBC driver will send the read-only queries automatically to true cache. Like the moment you invoke the read-only connections, all the queries will be automatically routed to the JDBC, routed to the true cache in fact instance. And if there's a write on this, then DLLs are automatically sent to the database level. This is called primary database. So this is something which normally gives you an upper hand, and you don't need to in fact do any kind of writing the custom code or something in fact. So everything is automated here. Now this is the 23 AI feature I told you. Now let's say some use cases. In fact, maybe you can see the true cache can use to support the variety of use cases. Like I've taken the 4 case of the out here. Say first one can be used, say mid-tier caching. Mid-tier caching is basically used for boosting the application performance. Okay, it can be used to cache as the second one is which something called the edge cache. Edge cache is basically for enabling the device proximity or the user proximity. This is for something what called the data sovereignty. And the third we call is something called multi-regions or multi-regions. For example, you want to use for data residency in fact. And we also have something called cloud cross cache. This is deployed again on the multi-cloud for providing the proximity of the data to the applications. So these are 4 different types of use cases where we can use the cache to do the depending upon the requirement you have it. Now, one slide is what is the benefit of what business get the benefit from you. So if you can talk a lot actually. So if you see primarily the benefit of using this true cache is the true cache basically it offers the several benefit. The first benefit I can say is it enables the significant cost saving, because the first cost saving is the cost of the developer. I mean, they don't have to write the code. Okay. Second thing is this, it has so much thing automated, then it has built-in feature. You don't have to do anything, just you configure the true cache and that's it, use it. Create the 2 connections, read only, write only, both connections, and JDBC driver automatically route you based on the query we have. So everything is automated here. Now, by improving the application performance, obviously, without having to rewrite those applications, nothing to rewrite application work as it is. In fact, it does not require any additional investment. Obviously, everything is built in. You just go and use it, configure it. In the new caching product or the new operation skill set, you don't require any kind of any skill set for this. You just require minimal skill set how to configure this caching. By default, we have already the documents. You can use it and follow it. It will not take, in fact, more than 20 minutes for that. Okay, the management and the operation skill for true cache are the same as the Oracle database, right? If you're the Oracle DB, you know how to work in the database, you can configure the caching. There's some certain parameter you need to configure both caching side and the primary side. That's it. Okay. Also, it can be used as a single cache for different data types and format. For example, documents, relations, rows, columnar, true cache can be deployed on the commodity hardware as well. I mean, it is not required that true cache should be on the high-end machine. No, any commodity hardware you can deploy these things. You may have the Dell machine, Intel machine, HP machine, heavy machine, in machine, you can deploy there. Okay, there's no any specific hardware required. And that could be, again, it could be in different size. And also, that can be used for running the Oracle database. And also, hardware should be, it also saves the hardware cost as well, right? The true cache offers the strong security. I told you we have the weaker security in the conventional machine, but in our case, we have the stronger security. Normally, every security which Oracle database possesses, that is inherited to cache. Okay. And we have some customer feedback which we have deployed. Due to we have masked the name of the customer. Yes, some feedback we have many customers who have already evaluating the true cache. One of them is one of the biggest stock chain in the world that is already evaluating our true cache to offload the read queries from some of the stock tickets. And the data in the true cache should be around something 10 terabyte. Okay. And then in the primary database, it could be something around 200 terabyte. Okay. So we will be working with one of the stock chain in the world, biggest in the world. And another thing is, we can deploy the 6 true, basically the purpose behind is there are, the same stock change, which is using something close to 200 node on the Redis cluster. And that 200 node is replaced by just placing the 6 true cache cluster. So you can see this tremendous change in the cost as well, right? There we have 200 Redis cluster that is serving the purpose of 200 terabyte. The same thing with the better performance, we are able to deploy on same configuration on the 6 true cache instances. So we are saving the huge hardware costs as well here. Also, one of the biggest mobile phone manufacturing is also integrating the true cache, is basically to offload their read queries. And the primary database is mixed with vertical scaling. And again, we have one of the biggest financial institution is we're also evaluating Oracle true cache to offload their fraud detections and application. And we have using exploring the AI model reference as the model can be trained. Okay. Along with this, we also have one of the biggest marketing company that is also evaluating the true cache. So in fact, we are doing this multiple POCs with all these customers, right? Now they are running this real time. They are running something huge campaign, and they need the real times marketing campaign, because in the campaigns you should always have the latest data, the most current data, right? So data in the conventional cache tend to get stale, as you know, because of the tweaking multiple feature things, right? Because application developer team has to code something, they have to show this thing. And along with this, we also evaluating the same product with the Oracle Fusion application to cache some of the complex business objects which have been nested relationship. Because I told you, nested relationship is not cached in the traditional one, but in our case, in cache. So these are the few examples we have, like Oracle. We are evaluating these things. And then again, we have one of the biggest bank is also evaluating the true cache to offload the read queries to cache and hence the improvement performance. So key take from here is, we will have again the live lab for the true cache. If you want to use it, we can provide you this thing, so you can get a feel of it. Okay. And in case you want to know more of the true cache, how true cache works, what architecture, what are the diagrams we have, the architecture we have, and how to, what are the things you need to configure. We have given the link out here. You can, from there, you can find this thing. Okay. Now, this was things very quick because, frankly speaking, this sharding itself is a very big topic. This is a big topic. But since the time constraint, I could not complete everything because this required at least for me 2 to 3 sessions to conclude the Oracle distributed database. Okay. We just talked about today the features of what distributed database has it. There's some use cases, then different types of the data distribution methods, different types of data replication methods, and then we discuss some kind of use cases, in fact, right? Okay. So let me answer the question here. I think a few of them I already answered. What is different between the true cache and the in-memory? What would be the use cases for the both, in fact? My dear friend, it depends in both cases. If you say true cache and in-memory, as I told you, true cache is the in-memory, is what you call a consistent in-memory, right? I told you in my definition. Now, both are different things. Let me give you an example here. In the true cache, there's no limitation how much you can store it, depending upon your memory you have it, right? So question here is, in the true cache, you have the options to offload the data, right? In case of in memory, because you have 2 types of request, read IO and write IOPS, right? In the in memory, how do you segregate the IOPS of read and write? In the true cache, only the read being offloaded, write is not being offloaded. So any customer who has analytical kind of data, OLAP kind of data, they have some reporting data, right? And they want to use this thing. So there could be the best example. As I told you, NYOUG exchange, fraud detections, mobile campaigning, all these examples which call the read-on data, right? So this is there. In memory is again something very different thing, because in memory is something you can use in the database, because database also has option called memory, they can use it. But both are different cases. And also the true cache can be deployed on the multiple data centers as high availability as well. Okay, so this can give you both high availability and scalability as well. In memory is something different. Now, other question is, diskless data guard, does it mean the true cache server should have memory equal to DB size? It's not required. It's not required. Traditionally, it should be, but if it is, it depends. Like it depends that how much data you want to cache, right? Because in true cache, you have, let's say in the primary databases, let's say 30 TB, right? But true cache, you want to say, let's say, cache it only, let's say 10 GB. That depends. It is not required, but it depends on how much data you want to cache in true cache. Yeah. How to determine the size of true cache server memory? See, my dear friend, this is again depends that amount of data. As I told you, like in my here slide, in fact, here, if you look this, yeah, we have offloading read queries for stock tickets to true cache with 10 TB of cache data for 200 TB. This means the size of data is 200 TB, the physical size, but they want to only cache 10 TB of the data here. Okay. So similarly, your question says same thing. So your question says size. Now this depends totally that how much data you want to cache. Now in your case, which I'm showing right now, the stock exchange says, in your case, the stock exchange says if they want to store, they want to cache only 10 TB of data out of 20 TB. So that depends again what kind of information you want to store here. Yeah. So that is totally dependent upon the requirement actually. Yes, any question we have? I still have some time. Let me see if I can show you the live link. Just give me a second.
Habib, one or two more questions. We have to wrap it up soon.
Yeah, please just give me 1 second. Let me show them this live lab one example. Maybe that would be helpful to use it. Okay. Let me share it again. The moment you open the link, you get this kind of screen out here, right? This one. This is live lab we have, right? So the moment you open this link, you will get this option called start. This is called green button. Now in the green button, see here, the moment you click it here, this is called running on your own tenancy. Now this will give you options in case you have any OCI tenancy. You click on this, right? Let me click on this. This will take me here, website. Now this is totally how to start the Raft, how to prepare the lab, right? We also have given the script to you. Yeah, here's the script here. It's here. Zip file, this one. This is the application. Just store the script and follow the steps. So in this case, if you have own tenancy, you can configure everything out here. Right? You can configure everything out here. These are steps how you work on the lab. So all the steps we have given here actually with the screenshot as well. What output you get it here. Now in case you choose the other options, that's what you call the green button. Let me again click on this. In case you choose the other option called sandbox. I think you can see my screen, right? You just choose run on the live lab sandbox. Now, if you click on this, in case you don't have an account on the, let's say OCI, just say run the live lab sandbox. This will provision this live lab for you, maybe in the maximum 10 to 15 minutes, and then you can use it. So this will give you option with, even though if you don't have access, you can use this. This will give you comprehensive understanding or comprehensive hands-on to work on the distributed database with the Raft replication. Yeah. Yeah, I think, let me come back to my screen. Yeah. Any question you have, guys, before we round up this thing?
Well, thank you, Habib, for today's presentation. Everybody has been interested in it. Most of everybody stayed on, and we look forward to continuing the webinars in 2025. And our first one coming up in January 17th will be Craig Shalahan. We'll be talking about AI. So you don't want to miss that. On behalf of NYOUG and Viscosity, I want to wish everybody a happy holiday, happy New Year. And thank you, Habib.
Thank you very much. Thank you very much, guys. Have a nice day. Yeah.
Thank you all. See you.
Thank you.
Bye.
Thank you. Bye-bye. Take care. Enjoy your days. Take care.